Well, g'day viewers. Well, I went to plug my Kinter in this morning, and this bloody thing, the socket snapped in half. The power socket snapped in pieces. Friggin' cheap shit. So I'm gonna take the power socket off my blown up Lapai LP838. That socket there is perfect. It's a lot better quality than this newer one. So, and when you think it's made by Lapai, it's not. It's made by Lapai. This was an LP838. I've done videos on this thing in the past. This is the one that blew up, audio modulating a ZVS and fed power back into the amp. So the chip was there, it's gone bang. Till pulled all the traces off the board, it was that well soldered on. I could not unsolder it. So I destroyed the board in the process. These connectors seem to be a bit better quality than the ones in the Kinter too. Yeah, actually are a bit better quality. And the Pi ones are a slightly better quality connector. I wonder if they're the same design. They'll connect on the same way. Not sure though. They might. 4 there. That's low profile. No, it won't fit. Bugger. Yeah, it's different. Otherwise I would solder this on as well because it's a better quality, but the pin spacing's too different. Footprint's different on the board. I don't know what sort of chip this thing uses. There's a preamp chip, 105 degrees Celsius for the capacitors too. Metal shafted pots, got a 2 spares there. That all has plastic shafted cheap pots. This is heavy duty metal pots. Anyway, let's swap the sockets over. Rather than waiting for the bloody cylinder to dry and for it to break again, so let's swap these over. I've got 16 volt, 22 watt microphone, and it's a FMZ brand, 105 degrees Celsius. This one's a 22 watt microphone, 16 volt Chong brand, 105 degrees Celsius as well. That's just a different brand. It's physically bigger, but unless I've got a spare part, I'll test it, see if it's alright. Let's open this thing up. I mean, desolder this thing. Open this thing up. All done, soldered straight in. It's not too bad quality either. The circuit board's an okay quality. It's not that little, it's dang it is paper based, but no, actually no, it's not. It's fiberglass based, I think. Better quality than this paper based one from Lapai. It's a Lapai board. It's actually a Lapai 838, but it's made by a company called Lapai. This one has a better quality circuit board. It costs the same price as the LP838 Lapai. So, both at a $9 to $12 mark. One thing I do recommend, especially with these little cheap ass amps, put some heatsink compound on these output chips. They'll last a lot longer and be happier. I've also had to insert the colour changing LED into the bezel. It was way over here, bloody near this capacitor. So now it's going to light up nice and bright and should be looking better again. Can take 2, but we've got 1 in there. Anyway, the soldering in general is pretty damn good. That's a Lapai. The LP838 looks good too, but it looks cheap, very cheap. LP2100 is a model board, and it's been modified for the LP838. But again, they've misled us and called it a Lapai when it's actually made by a company called Lapai. Made in Bukang. Yeah, it's cheap paperboard. Yeah, the Kinter is the same price but better quality. You're getting better quality here, so if you want to buy a good cheap amp for the same price you pay for that one, get a Kinter. Better quality internally. And the subwoofer output in this one, although it works, but man, it distorts. The main channels distort like buggery. Anyway, there's my heatsink compound. Let's put this back together. All properly put back in. That's better. That's very nicely packed in with heatsink compound. If I had done that in the factory, that one there had some in the factory too, but whatever heatsink compound it was the smallest dab you can think of, and it was dried out as soon as I opened that thing, as soon as I got it out of the box. Now I used it for a week, opened it up, and this heatsink compound, whatever they used, wasn't very good. So they put some of that unique stuff in there, good quality stuff. As to the pie, well, to get this apart, if I want to put some heatsink compound in it, which it may need some, I prefer to put some in there, but I've got to get the a Torx bit to fit those screws. This is a higher quality, this is our latest revision one. It's got to find a Torx bit to do undo those screws properly, and pull that apart and put a proper heatsink. The heatsink's in the middle inside here, separate from the case. So, and I don't use any heatsink compound in that either, so it's going to need some. There we go, all put back together. Nice. That will be much happier when it runs now. It won't get as hot, or will, but it'll be more efficiently cooling itself down. One neat feature I really like about the old CRT computer monitors is this. The degaussing feature is really handy. Let it get a good charge, and if you happen to mess it up with a magnet, you can always hit the degauss button. It's one thing I really liked about the old CRT monitors. And the colour's always good, better than the LCD. But I'm going to try and keep this and the Apple CRT, at least 2 CRT computer monitors, as well as CRT TVs, because these are damn rare for computer monitors now, the CRTs. There are certain applications where a CRT is good, so I'm going to try my hardest to keep it. Just got to find somewhere to store them in the meantime. When we move, it's going to be a bloody problem. Anyway, I really quite like these LCDs, they're good, but I always got to have one for comparison. Anyway, that'll be enough for now. Thanks for watching.